These are images of the Sun in visible light from NASA's Orbiting Solar Dynamics Observatory, or SDO. At visible wavelengths, the Sun is relatively featureless, its surface marked only with occasional sunspots carried into view by the Sun's rotation. These sunspots can change shape in hours or stay stable for days. Ultraviolet light on the Sun is created by energetic ions guided by magnetic fields, so these magnetic fields form glowing lines in ultraviolet images from SDO. The magnetic fields are more intense near sunspots, forming loops of plasma called coronal loops, which change and grow in seconds. In ultraviolet light, the Sun appears very active. Using images from SDO in different wavelengths and polarizations, maps of the magnetic field at the Sun's surface can be created. In these magnetograms, white and black indicate strong magnetic fields pointing out of and into the Sun, while gray indicates weak magnetic fields. Coronal loops form between regions of intense opposite magnetic fields. From these magnetograms, we can create models of the solar magnetic field above the surface of the Sun. This particular model is called the Potential Field Source Surface Model, or PFSS. The Sun's rotation has been stopped so that the magnetic field lines are easier to see. Many of these lines curve and connect back to the solar surface on both ends. We call these field lines closed and color them white. The highest concentration of such lines is in regions of intense magnetic field. These are called active regions, and the closed lines in these regions closely match the coronal loops visible in ultraviolet light. Other field lines emerge from the surface and head off into space. We call these field lines open and color them green if they emerge from a positive magnetic field region, or violet if they emerge from a negative field region. These open field lines often correspond to regions called coronal holes, which provide a fast track for charged particles to leave the Sun and become part of the solar wind. Magnetic fields are everywhere in space, but we can only draw some of the lines that show the shape of the field near the Sun. As the magnetogram on the surface changes, so do the shapes of the lines. You may notice jumps in the field lines as they change in time. This visualization shows 4 years of the Sun's magnetic field. The magnetic field extends outward to cover the entire solar system and beyond, interacting with all of the planets. By studying the magnetic field at the Sun's surface, we are gaining insight into the nature of the vast region dominated by our Sun.